The Triassic period was the first period of the Mesozoic era and occurred between 251.9 million and 201.3 million years ago. It followed the Great Mass Extinction at the end of the Permian period and was a time when life outside of the oceans began to diversify. At the beginning of the Triassic, most of the continents were concentrated in the giant C-shaped supercontinent known as Pangaea. Triassic climate was generally very dry over much of Pangaea, with very hot summers and cold winters in the continental interior. A highly seasonal monsoon climate prevailed nearer to the coastal regions. Late in the Triassic, seafloor spreading in the Tethys Sea led to rifting between the northern and southern portions of Pangaea, which began the separation of Pangaea into two continents, Laurasia and Gondwana, which would be completed in the Jurassic period. The oceans had been massively depopulated by the Permian extinction, when as many as 95% of extant marine genera were wiped out by high carbon dioxide levels. Fossil fish from the Triassic period are very uniform, which indicates that few families survived the extinction. The mid to late Triassic period shows the first development of modern stony corals and a time of modest reef-building activity in the shallower waters of the Tethys near the coasts of Pangaea. Early in the Triassic, a group of reptiles, the order Ichthyosauria, returned to the ocean. Fossils of early ichthyosaurs are lizard-like and clearly show their tetrapod ancestry. Later in the Triassic, ichthyosaurs evolved into purely marine forms with dolphin-shaped bodies and long-toothed snouts. Their vertebrae indicate they swam more like fish, using their tails for propulsion with strong fin-shaped forelimbs and vestigial hindlimbs. By the mid-Triassic, the ichthyosaurs were dominant in the oceans. One genus, Shonisaurus, measured more than 50 feet long or 15 meters and probably weighed close to 30 tons or 27 metric tons. Plesiosaurs were also present, but not as large as those of the Jurassic period. Plants and insects did not go through any extensive evolutionary advances during this period. The interior of Pangaea was mostly desert due to the dry climate. In higher altitudes, gymnosperms survived and conifer forests began to recover from the Permian extinction. Mosses and ferns survived in coastal regions. Spiders, scorpions, millipedes, and centipedes survived, as well as the newer groups of beetles. The only new insect group of the Triassic was the grasshoppers. Triassic reptiles. Two groups of animals survived the Permian extinction: therapsids, which were mammal-like reptiles, and the more reptilian archosaurs. In the early Triassic, it appeared that the therapsids would dominate the new era. One genus, Lacerda, has been called the Permian/Triassic Noah, as fossils of this animal predate the mass extinction but are also commonly found in early Triassic strata. However, by the mid-Triassic, most of the therapsids had become extinct and the more reptilian archosaurs were clearly dominant. Archosaurs had two temporal openings in the skull and teeth that were more firmly set in the jaw than those of their therapsid contemporaries. The terrestrial apex predators of the Triassic were the Rhynchosaurs, an extinct group of archosaurs. Proterosuchus chinicensis, an extant genus of pseudosuchian, measured more than 20 feet or 6 meters in length. Unlike their close relatives, the crocodilians, Rhynchosaurs had an upright stance, but are differentiated from true dinosaurs by the way that the pelvis and femur were arranged. Another lineage of archosaurs evolved into true dinosaurs by the mid-Triassic. One genus, Silesaurus, was bipedal. Although smaller than the Rhynchosaurs, they were probably faster as they had a more flexibly jointed hip. Silesaurus also picked up speed by having lightweight hollow bones. They had long, sinuous necks, sharp teeth, clawed hands, and a long bony tail. Some of the individuals found had remains of smaller members of the species inside the larger animals. Scientists are unclear as to whether this indicates internal gestation or possibly cannibalistic behavior. By the late Triassic, a third group of archosaurs had branched into the first pterosaurs. Charavipteryx was a glider about the size of a modern crow, with wing membranes attached to long hind legs. It was obviously bipedal, with tiny clawed front feet that were probably used to grasp prey as it jumped and glided from tree to tree. Another flying reptile, Herrerosaurus, was much smaller, only the size of a hummingbird, with wing membranes sprouting from modified ribs. Earliest mammals. The first mammals evolved near the end of the Triassic period, from the nearly extinct therapsids. Scientists have some difficulty in distinguishing where exactly the dividing line between therapsids and early mammals should be drawn. Early mammals of the late Triassic and early Jurassic were very small, rarely more than a few inches in length. They were mainly herbivores or insectivores, and therefore were not in direct competition with the archosaurs or later dinosaurs. Many of them were probably at least partially arboreal and nocturnal as well. Most, such as the shoe-like Eosostrodon, were egg-layers, although they clearly had fur and suckled their young. They had 3 ear bones like modern mammals and a jaw with both mammalian and reptilian characteristics. Herrerosaurus. Herrerosaurus is likely a genus of Saurischian dinosaur from the late Triassic period. This genus was one of the earliest dinosaurs from the fossil record. Its name means Herrera's lizard, after the rancher who discovered the first specimen in 1958 in South America. All known fossils of this carnivore have been discovered in the Ischigualasto Formation of the Carnian Age, dated to 231.4 million years ago, in northwestern Argentina. The type species was described by Osvaldo Rieck in 1963 and is the only species assigned to the genus. For many years, the classification of Herrerosaurus was unclear because it was known from very fragmentary remains. However, with the discovery of an almost complete skeleton and skull in 1988, Herrerosaurus has been classified as an early Saurischian in most of the phylogenies on the origin and early evolution of dinosaurs. Herrerosaurus was a lightly built bipedal carnivore with a long tail and a relatively small head. Adults had skulls up to 56 centimeters or 22 inches long and were up to 6 meters or 20 feet in total length, and 350 kilograms or 770 pounds in weight. Smaller specimens are about 4.5 meters or 15 feet long and weighed about 200 kilograms or 440 pounds. Herrerosaurus was fully bipedal. It had strong hind limbs with short thighs and rather long feet, indicating that it was likely a swift runner. The tail, partially stiffened by overlapping vertebral projections, balanced the body and was also an adaptation for speed. The first 2 fingers and the thumb ended in curved, sharp claws for grasping prey. The 4th and 5th digits were small stubs without claws. The teeth of Herrerosaurus indicate that it was a carnivore. Its size indicates it would have preyed upon small and medium-sized plant eaters. These might have included other dinosaurs, such as Pisanosaurus, as well as the much more plentiful Rhynchosaurs. Herrerosaurus itself may have been preyed upon by giant Rauisuchians, like Saurosuchus. Puncture wounds were found in one skull. Thrinaxodon. Thrinaxodon is an extinct genus of cynodonts, which lived in what are now South Africa and Antarctica during the early Triassic. Thrinaxodon lived just after the Permian Triassic mass extinction event. Its survival during the extinction may have been due to its burrowing habits. Similar to other therapsids, Thrinaxodon adopted a semi-sprawling posture, an intermediary form between the sprawling position of basal tetrapods and the more upright posture present in current mammals. Thrinaxodon was a small synapsid, roughly the size of a fox, and possibly covered in hair. The dentition suggests that it was a carnivore, focusing its diet mostly on insects, small herbivores, and invertebrates. Their unique secondary palate successfully separated the nasal passages from the rest of the mouth, allowing the Thrinaxodon to continue mastication without interrupting to breathe, an adaptation important for digestion. Paleontologists are not yet sure if early cynodonts had evolved fur, one of the hallmark traits of mammals, but it is quite possible that critters such as Thrinaxodon had furry little bodies. Small pits that dot the snout of this cynodont suggest that it sported sensitive whiskers, which supports the hypothesis that it had a form of hair. Whiskers are very sensitive to touch, making them useful for navigating the dark burrows that Thrinaxodon lived in. Many species have been found fossilized in their burrows as they slept, sometimes even in groups. Other Thrinaxodon weren't the only animals that visited their cozy burrows. One noteworthy fossil shows a Thrinaxodon sharing its home with a small amphibian called Brumistega, which apparently took shelter in the burrow after being injured by a large carnivore. Although Thrinaxodon was itself a carnivore, the bite marks on the Brumistega do not match up with the jaws of its roommate. Henodus. Henodus is an extinct placodont of the late Triassic period that lived mostly during the early Carnian age. Fossils of Henodus Caliops were found in Germany. It was around 1 meter or 3.3 feet in length. Henodus is the only placodont thus far found in non-marine deposits, suggesting it may have lived in brackish or freshwater lagoons. Like many other placodonts, Henodus had a superficial resemblance to a turtle. Like turtles, it had a shell formed from a plastron on the underside and a carapace on top. The carapace extended well beyond the limbs and was made up of individual plates of bony scutes covered by plates of horn. However, the shell was composed of many more pieces of bone than that of turtles, forming a mosaic pattern. The armor was fused to its spine, and its limbs were situated in normal positions, unlike the turtle, where they are located inside the ribcage. The weak limbs of Henodus suggest it spent little, if any, time on land. Henodus also had a single tooth on each side of its mouth, though a beak replaced the remaining teeth. In addition, it had baleen-like denticles along the jaws, indicating a filter-feeding lifestyle. Silesaurus. Silesaurus, a member of the Silesaurid dinosauriform genus, roamed the late Triassic landscapes of present-day Poland. The type species, Silesaurus opelensis, was described by Jerzy in 2003. It is known from some 20 skeletons, making it one of the best represented species of early dinosauriforms. Silesaurus measured approximately 2.3 meters or 7.5 feet in length. With a slender frame, it likely possessed swift agility, suggesting an energetic and active lifestyle. The snout was narrow with forward-pointing nostrils, and the large orbits likely provided Silesaurus with acute vision. Initially, Silesaurus was thought to be strictly herbivorous, but later research on coprolite contents indicates that it may have been insectivorous, feeding on insects such as the beetle Chiamyxa. The teeth of the animal were small, conical, and serrated, and were distributed irregularly in its jaws. The tip of the dentary had no teeth, and evidence suggests that it was covered by a keratinous beak. While Silesaurus could exploit plant resources, it was not strictly a plant eater. The teeth of Silesaurus were not numerous or regularly spaced, and lacked the coarse serrations typical in herbivores. The beak-like jaws were adapted for pecking small insects off the ground like modern birds. Silesaurus and Silesaurids in general have been considered quadrupedal due to their long, gracile forelimbs. In 2010, the paleontologists Raphael Piechowski and Jerzy considered such proportions typical of fast running. The long tail of Silesaurus which would have acted as a counterweight to the body, as well as the very gracile forelimbs, indicates it retained the ability for fast bipedal movement. Rhynchosaur. Imagine a reptilian pig with a hammerhead, no visible ears, and a parrot-like beak, and you'll have a pretty good mental picture of a rhynchosaur. Rhynchosaurs were a group of herbivorous archosauromorphs that ranged all over the world in the Triassic period. In some places, they were the most abundant plant-eaters on land, and they made up an important part of terrestrial faunas before the rise of plant-eating dinosaurs near the end of the Triassic. The early rhynchosaurs were small, less than a meter long, and had narrow wedge-shaped skulls and a few small blunt teeth for eating plants. Some other early archosauromorphs, such as Trilophosaurs, were also herbivorous. It is not clear whether Rhynchosaurus were closely related to these other herbivores or not. In some studies, Rhynchosaurs were found to be close relatives of Choristoderes, which were mostly aquatic predators. Later Rhynchosaurs, like Hyperodapodon, were up to 2 meters long and had very wide skulls and large beaks. Their skulls were much wider than they were long or tall, which gave them a hammerhead appearance, although the eyes were set close together near the top of the beak. Rhynchosaurs had many rows of small teeth closely packed together in the upper and lower jaws, like kernels of corn on a cob. These plate-like arrays of teeth formed surfaces for cutting and crushing plant material. Cymbospondylus. Cymbospondylus, among the earliest members of its kind, is an extinct genus of large ichthyosaurs. These marine reptiles thrived during the Middle Triassic period, inhabiting regions that are now North America and Europe. The first known fossils of this taxon are a set of more or less complete vertebrae, which were discovered in the 19th century in Nevada before being named and described by Joseph Leidy in 1868. Cymbospondylus was formerly classified as a representative of the Shastasauridae, but more recent studies consider it to be more basal. As an ichthyosaur, Cymbospondylus had flippers for limbs and a fin on its tail. Cymbospondylus has a very slender profile, unlike later ichthyosaurs, which have a morphology similar to those of dolphins. The different species of Cymbospondylus vary greatly in size, with the smallest reaching around 4 to 5 meters, or 13 to 16 feet in length. The largest known species, Cymbospondylus youngurum, is estimated over 17 meters, or 56 feet long, making Cymbospondylus one of the largest ichthyosaurs identified to date, but also one of the largest animals known of its time. The teeth are conical and pointed, having longitudinal ridges, indicating a diet of fishes and cephalopods, and possibly other marine reptiles for larger species. Cymbospondylus is important in the study of ichthyosaur evolution and the marine ecosystem of the Triassic period. Its fossils provide valuable information about the diversity, anatomy, and behavior of early marine reptiles, helping scientists reconstruct ancient marine environments and understand the evolutionary transitions that occurred during this time. Nothosaurus. Nothosaurus is a genus of extinct marine reptiles alive during the Triassic period, approximately 241 to 200 million years ago. It lived in parts of North America, Europe, and Asia, and was among the most abundant marine reptiles of the Triassic period. Unlike the other popular groups of marine reptiles that were fully aquatic, Nothosaurus lived a semi-oceanic lifestyle. Like modern seals, this reptile spent significant time on land, but was well adapted to life in the ocean. The paleontologists that described the Nothosaurus weren't certain of how to classify it because it looked like a land-dwelling animal, but it was not quite like them. This is why it got the name false lizard. Although it was not as big as later Mesozoic-era reptiles like the plesiosaurs and plesiosaurs, it still reached lengths of about 4 meters or 13 feet on average. The tail and its long webbed feet helped the Nothosaurus propel its slender body through the water. The jaws were lined with rows of fang-like teeth that were effective for holding on to prey. It moved by undulating its slender body while steering its body through the water using its webbed feet. Its streamlined body shape made it possible to navigate the water with relative speed and agility. On land, Nothosaurus moved by waddling its paddles through the soft sediments. After mating, the female Nothosaurus would have laid eggs like other reptiles. Although some marine reptiles, such as ichthyosaurs and plesiosaurs, gave birth to live young in the water, semi-aquatic forms like the Nothosaurus spent a lot of time on land. This suggests that their life cycle was probably more similar to that of present-day reptiles like turtles and crocodiles. Placerias. Placerias is an extinct genus of dicynodonts that lived during the Carnian to the Norian age of the Triassic period, 230 to 220 million years ago. It belonged to a larger group called Dicynodontia, which was one of the most successful and diverse groups of herbivores during the Permian and Triassic periods. Placerias fossils have been found in North America, particularly in the Chinle Formation of Arizona and New Mexico. Placerias was one of the largest herbivores in the late Triassic, measuring 3.5 meters or 11 feet long and weighing up to 800 to 1,000 kilograms, 1,800 to 2,200 pounds. The largest skull found had a length of 68 centimeters or 26.8 inches. Placerias had a powerful neck, strong legs, and barrel-shaped body. There are possible ecological and evolutionary parallels with the modern hippopotamus, spending much of its time during the wet season wallowing in the water, chewing at bankside vegetation. Remaining in the water would also have given Placerias some protection against land-based predators, such as the Proterosuchus. Placerias used its beak to slice through thick branches and roots with two short tusks that could be used for defense and for intraspecific display. Morganucodon. Morganucodon is an early mammaliform genus that first appeared about 205 million years ago and lived from the late Triassic to the Middle Jurassic. Unlike many other early mammaliforms, Morganucodon is well represented by abundant and well-preserved material. Most of this comes from Glamorgan in Wales, Morganucodon watsoni, but fossils have also been found in Yunnan province in China and various parts of Europe and North America. Morganucodon was a small plantigrade mammal, the tail of which was moderately long. The skull was 2 to 3 centimeters in length, and the body measured about 10 centimeters, or 4 inches. In general appearance, it would have looked like a shrew or a mouse. There is evidence that it had specialized glands used for grooming, which may indicate that, like present-day mammals, it had fur. Morganucodon was likely nocturnal and spent the day in a burrow, though there is no direct fossil evidence. Likewise, burrowing was widespread both in non-mammalian cynodonts and in primitive mammals. Plant material from the conifer Herrerosaurus was also found in the fissure fills, indicating Morganucodon lived in or near a forested area. The diet appears to have been insects and other small animals, with a preference for hard prey such as beetles. Like most modern mammal insectivores, it grew fairly quickly to adult size. Its eggs were probably small and leathery, a condition still found in monotremes. The combination of rapid growth in juveniles and a toothless stage at infancy strongly suggest that Morganucodon raised its young by lactation. Indeed, it may have been among the first animals to do so. Temnospondyls. Temnospondyls is a diverse ancient order of small to giant tetrapods, often considered primitive amphibians, that flourished worldwide during the Carboniferous, Permian, and Triassic periods, with fossils being found on every continent. A few species continued into the Jurassic and early Cretaceous periods, but all had gone extinct by the late Cretaceous. During about 210 million years of evolutionary history, they adapted to a wide range of habitats, including freshwater, terrestrial, and even coastal marine environments. Temnospondyls reached a peak diversity during the early Triassic and progressively declined throughout the subsequent Middle and Late Triassic, with only 4 members of the Brachiopoda surviving into the Jurassic and the Cretaceous. The diet of Temnospondyls varied depending on the species and size, but most were carnivorous, feeding on fish, smaller amphibians, insects, and other small vertebrates. Some larger species may have been opportunistic predators, scavenging on larger prey or even consuming plant matter. Temnospondyls, like most modern amphibians, reproduced in aquatic environments. Most Temnospondyls probably reproduced through external fertilization. Like most living frogs, female Temnospondyls would have laid masses of eggs in water while males released sperm to fertilize them. Shonisaurus. Shonisaurus is a genus of very large ichthyosaurs. At least 37 incomplete fossil specimens of the marine reptile have been found in the Luning Formation of Nevada, USA. This formation dates to the late Carnian age of the late Triassic period, about 237 to 227 million years ago. With a large skull about 2.75 meters or 9 feet long, Shonisaurus popularis measured around 13.5 to 15 meters or 44 to 49 feet in length and 21.6 to 29.7 tons in body mass. Shonisaurus sicaniensis was one of the largest marine reptiles of all time, measuring 21 meters or 69 feet and weighing 81.5 tons. Shonisaurus had a long snout, and its flippers were much longer and narrower than in other ichthyosaurs. While Shonisaurus was initially reported to have had socketed teeth, rather than teeth set in a groove as in more advanced forms, these were present only at the jaw tips, and only in the very smallest juvenile specimens. Shonisaurus possessed teeth in all ontogenetic stages. It was historically depicted with a rather rotund body, but studies of its body shape since the early 1990s have shown that the body was much more slender than traditionally thought. Proterosuchus. Proterosuchus is an extinct genus of archosauriform reptiles that lived during the early Triassic. It contains 3 valid species, and all 3 species lived in what is now South Africa. The genus was named in 1903 by the South African paleontologist Robert Broom. Proterosuchus was a mid-sized quadrupedal reptile with a sprawling stance that could reach a length of up to 3.5 meters, or 11 feet. It had a large head and a distinctively hooked snout. It was a predator, which may have hunted prey such as Lacerda. Debates persist regarding the lifestyle of Proterosuchus, with hypotheses suggesting it could have been either terrestrial or a semi-aquatic ambush predator, akin to modern crocodiles. Proterosuchus was likely a carnivore, preying on smaller animals such as insects, amphibians, and early reptiles. Its sharp teeth and agile body would have made it well suited for hunting and capturing prey. Proterosuchus had mesopic vision, indicating that it was adapted to see well in both bright and dim light. Mesopic vision is characteristic of cathemeral animals, which are active in both day and night, and crepuscular animals, which are active in twilight. Adaptations to see in dim light may have been ancestral to archosaurs, and Proterosuchus may have been an early example of this trend. Desmatosuchus, an extinct genus belonging to the order Aetosauria, thrived during the late Triassic period. Desmatosuchus was a large quadrupedal reptile measuring 4.5 meters or 15 feet to over 5 meters or 16 feet long and weighing about 280 to 300 kilograms, 620 to 660 pounds. This archosaur's most distinguishing anatomical characteristics were its scapulae, which possessed large acromion processes commonly referred to as shoulder spikes. The forelimbs were much shorter than the hind limbs, with humeri less than 2/3 the length of the femurs. Its skull was relatively small, on average about 37 centimeters long, 18 centimeters wide, and 15 centimeters high. The brain case was very firmly fused with the skull roof and palate. It had slender, forked premaxillae that turned up and expanded in the front, creating a shovel-like structure. Desmatosuchus is unique among aetosaurs in that its species are the only known ankylosaurs that lacked teeth on their premaxillae. Their premaxillae fit loosely together with their maxillae, indicating flexibility at that joint. Their maxilla contained 10 to 12 teeth. The lower jaw typically carried 5 or 6 teeth and had a toothless beak on the end. The dentary was about half the length of the lower jaw, with the front portion being toothless and covered by a horny sheath. Behind the dentary was a moderately large mandibular fenestra. Individuals of Desmatosuchus were heavily armored. The carapace was made up of 2 rows of median scutes, surrounded by 2 more rows of lateral scutes. Like many other late Triassic reptiles, Desmatosuchus eventually became extinct towards the end of the Triassic period, possibly due to environmental changes or competition from other emerging groups of reptiles.